Hi guys, welcome to Algebra 2 Semester 1. We're going to be starting with graphing to solve systems of linear equations. So you're going to want to get out a notebook, piece of paper, a pencil, and stuff to write on and take these notes. Let's go ahead and get that ready and then move on when you are. So first, let's start off by talking what is a system of linear equations and what is its solution. A system of linear equations is more than two linear equations. So we can have like y equals x, y equals 2x plus 4. These are both linear equations, so this is a system of linear equations. Oh, sorry, this should be more than one. It just has to be more than one. A solution to a system is the variable values that make both equations true. So what we mean by true is both sides equal each other. Equal the same number. So for example, let's see if 2, 5 is a solution to this point, and if 1, 1 is a solution to this point. So that means it'd make it true. So everywhere I see a y, I'm going to put a 5. So 4 minus 1 is 3. And 5 does not equal 3. So this is not, it's not true, so this is not a solution. I can do the same with the 1 and 1. Everywhere I see a y, I'm going to put a 1, and everywhere I see an x, that's true. So this is a solution. So a solution is something that makes an equation true. If it's a solution to a system, that means it'd make every equation true, and we'll see this more in the next slide. So if you have questions, write down what page number your question's on. Okay, so it gives us two linear equations, and it gives us a bunch of x, y points. So I will do the first two with us, and then you can do the next two on your own. So I'm going to put an 8 everywhere I see an x. So I'm going to show my work for testing 8, 4. So you're going to want to write this with me. So everywhere I see an x, I'm going to put an 8. Everywhere I see a 3, everywhere I see a y, I'm going to put a 4. So I have a good here. Now let's go ahead and try 8, 4 in the second equation. And then when I solve this, that's not check marks. That's not true. So therefore, I would answer this because I don't have two true, like it's not, 8, 4 is a solution to the first equation, but not the second equation. So it would be no. I can go ahead and try -3, 9. So everywhere I see an x, I'm going to put in a -3. Everywhere I see a y, I'm going to put a 9. Okay, 21 does not equal 4. So we know this is going to be an x. I can still try it in the second one though. It would still make this answer no. So but we can put it in the -7 times -3. So even though it's true for one of them, and it's a solution for one of them, it's not a solution for both of them, so it's not a solution for the whole pair. Go ahead, pause your screen. I want you guys to try the -2, -1, and the 0, 5 on your own. Okay, so this chart at the bottom articulates what you should have gotten. You should have gotten no for both of these, so pause this if you need to see the math on how they got no for those 2 points. So next we're going to talk about the number of solutions that a system could have. So if the lines intersect at one point, there's one solution, so it intersects there. And this is called consistent independent. If lines are parallel, there's no solution because they never cross each other. And this is called inconsistent. If both equations are the same line, if we have one line, there's infinitely many solutions because you can think of it, the lines are always on top of each other. So it may sound kind of weird to think about it this way, but think of it, it's like, oh, it's really like a line on top of a line. So they overlap at every point. So that's why they have infinitely many solutions. So you're going to want to write down these definitions in these words. Okay, so this asks us to look at these are the equations, this is the graph, and then decide what type of system it is and how many solutions it has. So I see here that it's the same line. If you look at the slide before, same line means it's consistent dependent. And also if they're the same line, then they're constantly on top of each other and overlapping. So every point is a potential solution, so it's infinitely many solutions. These lines never cross. If you look at the page before, we see that it's an inconsistent. And because they never cross, we have no solution. I'm going to pause the screen, try this last one on your own. So we would see that it's consistent independent and that it crosses once, and this is the point negative or +3, -3. So I would say it has a unique single solution of +3, -3. So remember how to graph a line. We put an equation in slope-intercept form where we have y equals mx plus b, or m is our slope, which is rise over run, or y2 minus y1 over x2 minus x1. B is our y-intercept, so remember that's where it crosses the x-axis, or that's where it crosses the y-axis. Sorry, the y-intercept is where it crosses the y-axis. A negative slope looks something like going in that direction. A positive slope means it's going in this direction. So now let's take the time to look at this graph. I see that it got my y-intercept of 4. So that's where it got that 4. And there's a couple different ways you can see that it got the slope. Our rise was 1, and then it went over 2. So up 1 over 2. So my rise over run was up 1 over 2. So if you're given a graph, that's a way to think about it. So that's how it got the 1/2. And then our 4 was our y-intercept. Okay, so this is asking us to graph the system. I'm going to, and then say how many solutions it has. So I'm going to go ahead and do this system in blue first. But it is not in the form y equals mx plus b. So I can go ahead and get it in that form. So that's a -1/3x minus 2. So I go over here to try to graph that. I start at -2, I rise 1, and then I have a negative slope, so I go over 3. Or you can think of it as fall. You can think of it as fall 1, run 3, fall 1, run 3. Okay, my line is going to be imperfectly connected, but this is what it would look like. I want you to pause the screen and try to do the other one. I'm going to do the other one in a different color, but go ahead and pause the screen and try to graph this line on your own. It's already in y equals mx plus b form for us. So I'd start at -3, down 1/3. And then we see that these lines never cross. So our answer would be no solution. And if we think about it, that makes sense because our slopes are the same, so they're parallel. Okay, we're gonna go ahead and try this one. Go ahead and try to do it on your own first, and then I will walk you through it. Okay, so I still want it to be in a form y equals mx plus b. So I start at -7. I'd start at -7 up to over 1. And then this green one is already in the correct form, which is helpful. It's in y equals mx plus b, so up 1/2, up 1/2, up 1/2. I see that they crossed here. So my system would be, that's 4, 1 is my solution. Okay, now we're going to talk about how to write equation given a line. So remember, our equation is to y equals mx plus b. My b is my y-intercept, and we can just look at the graph. So for this equation, my b equals 4. Remember, this is my rise over run. or y2 minus y1 over x2 minus x1. So I'm going to treat it like rise over run. If you want to think of it a different way, you can. So I'm going to pick 2 points down here so the graph isn't as messy. I go up 2 over run. So I rise 2. I go over 1. So my m equals 2. And then eventually I get y equals m x plus my b of 4. So that'd be the equation here for this line. We're going to take this into consideration moving forward. Okay, so it wants us to graph these 2 lines. We're going to call this line 1, line 2. So for line 1, I need y equals mx plus b. I see that because of this, my b equals -1, which is awesome. Now I'm going to think of how much I rise and how much I run. I rose 3. I ran 2. So I rose 3, ran 2. So rise over run. And that's what that equation would look like. For line 2, we have y equals mx plus b. Let's think about what our b is. B would equal -5, so I know that's -5. I still need my rise over run. I can also draw it this way, 3 and 2. So my rise is 3, my run is 2. So these are the equations for both lines. You guys are going to try the next slide on your own. Okay, here's a worked out solution for each line. This line would be -2x plus 3. The biggest thing I want to talk about is why it's negative, is because it's going in that direction. The plus 3 is, here's my b equals 3. And then I can see from most of these that my rise is 1, or my rise is 2 and my run is 1. For this equation down here, that's this line. This stuff is also explained more over here. I can see I'm running 3 and rising 1, so it's 1 over 3. And then I can see my b equals -2. Okay, good job. This is skill 1. So you want to be taking these notes as you go. Write down slide numbers if that helps you to ask your teacher questions.